All right. A very good afternoon to everyone. I hope everyone is having a great conference. I know I am. I'd like to spend the next 25 minutes talking about a very important browser security mechanism called private network access. We'll talk about what a short life it had and what a long shadow it leaves behind. A quick intro. My name is Gav. I'm a security engineer. I work out of Philly. I'm lucky to be joined by some of my amazing colleagues at the place I work. And in about 25 minutes, I'll have the privilege to be a B-side speaker. A quick disclaimer before I start. This is a personal project that I conducted on weekends. All the views expressed are my own. Any tools that you see here, please only use them in trusted environments and places that you have permission to test on. All right. Can I have a quick show of hands for anyone who has seen these HTTP headers? A quick show of hands. Awesome, a couple of folks. Great. Quick point, not to be confused with the CORS headers. He's slightly different. But nevertheless, let's move along. How about this pesky alert? Anyone seen this? Okay, I see a few more hands. Great. So if you're a Chrome user and you've upgraded to Chrome 142 in the last 3 months, there is a high possibility you might have seen this alert. Now, the two that you saw here are essentially two things trying to solve the same problem, but in very different ways. Let's see what the problem is. Browsers are a very important trust boundary, and specifically a network trust boundary. Why is that so? Because it lets the internet talk to, or rather access, our private networks, right? It can be your home network, it can be your enterprise network, or your local host as well, right? Services running on your local host. And that trust boundary has been exploited for a very long time. For example, for port scanning. A couple of years ago, every public almost all public websites were scanning their. Let me rephrase that. Not all, but quite a few public websites were found port scanning their users. Why so? Because honestly, it's a great way to fingerprint users in a stateless manner. The trust boundary was also being exploited for something more nefarious, for something called as drive-by attacks. So an age-old technique called SOHO farming. What's that about? Say you access a public website and it tries to send a fetch request to your router to set the DNS server on it. All right, let's say your DNS server is misconfigured. You end up hijacking the victim's network there. Or for something as recent as CV 2025 49596. Now that was concerning MCP inspector. Right, that's basically a tool that lets you inspect a bunch of MCP protocols that you might be testing. And if a public website manages to get a user to click their link and execute this command, they'd end up having a shell on that system, on that host rather. So one way browsers decided to solve that problem was by a mechanism called private network access, or PNA. When it was rolled out, it was also called CORS RFC 1918. Now, for those who are familiar with CORS, you'll see why the name sounds very similar. To get to know what PNA is, it's important to first understand what pre-flight requests are. Say, for instance, you live in an apartment building, and a stranger walks up to the bellman and asks them, "Hey, I want to visit Mr. XYZ on floor number N." All right. That bellman is going to call you and ask you for your permission. Can I send that stranger up there? Are you expecting them? And depending on what the person on the floor upstairs responds back, the bellman is essentially going to allow or not allow that stranger to come up there. That exact concept is what PNA uses. So say you open a public website and it tries to initiate a connection to something private. Right, something on localhost, something in RFC 1918, the browser is going to step in and do something called as a pre-flight request. It would first send an options request to that private resource, requesting private network. So access control private network to true. is going to request that access. Only if that private resource responds back with the 200 OK with the explicit headers, access control, allow private network as true, and it reflects back the origin, only then does the browser know that this private connection is authorized by the private resource itself. And PNA is exactly this pre-flight request. If you're familiar with CORS, this particular pre-flight request should look very similar, right? Just the headers are different. All right, let's look at the timeline of implementation for PNA. So Chrome initially proposed CORS RFC 1918 to the World Wide Web Consortium back in November 2020. PNA first made its appearance in any browser in Chrome 96 in November 2021. Early 2022, it started throwing errors in case private network access was detected. But by September 2023, it was full-blown blocking access if using PNA. That was in September 23. September 24, the World Wide Web Consortium officially accepted it as a draft for a specification to be included in other browsers as well. But in September 2025, something happened. We'll talk about that a little later. So a little backstory. I personally work in web app security, and I personally stumbled across PNA earlier this year, to my shame. And in June 2025, I was a little curious to analyze what the state of PNA is. So what I did was I chose the largest lab space prod space lab/prod space available, which is AWS US East 1. I analyzed all web services on port 80 using a custom Nmap script. So essentially, I send that pre-flight request to see who responds back with those headers. So on the right, you'd see 2 million IPs responded back with a valid web service on port 80, but only 0.1% of them actually responded back with any kind of PNA headers in there. Surprisingly, 2/3 of them blocked private network access, but 1/3 of them allowed private network access. I gathered some additional information like what kind of servers are these? Surprisingly, a vast majority of them were Nginx. I gathered some title information. What I saw was most of them, a vast majority of them did not have any kind of titles. So my interpretation was that PNA adoption is low. About 1/3 of PNA-enabled servers seem to have an insecure configuration. And the lack of titles in these web services probably indicate that these are some kind of APIs. If you'd like to test this in your own environments, please feel free to use the Nmap script and the nuclei template here. If you're a nuclei kind of person, feel free to use either of the two. All right, I'll leave that up there for a second. Perfect. So let's all go back home and make sure all our private resources support PNA headers, right? Unfortunately, no, it's not as simple as that. In September this year, just 3 months ago, the only browser that supported PNA decided to deprecate PNA and replace it with something called local network access. So private network access became local network access. Though the two mechanisms sound awfully familiar or similar in name, there is a very big difference in the two. And that difference is a shift in responsibility. In PNA, it was up to the service, the local or the private service to protect itself, right? It had to allow PNA access using those headers explicitly. But that model has shifted, or that responsibility has shifted to the user in LNA. And how does it manage to achieve that? Using this very elementary prompt. So anytime the browser sees or intercepts that private network or that network access to something local or private in private IP space, is going to throw you that error. Unfortunately, so that entire pre-flight request that we saw is being replaced by this. Now, depending on what side of the security spectrum you are on, you're either going to end up always allowing, always denying, or rolling the dice on what to select for allowing or blocking that request. So I wrote up a quick Chrome extension. It's currently available on the Chrome store. So on the left, you'd see what that alert looks like, right? So in case you see that pop up, you hover over the extension, and it's going to exactly tell you the URL that public website is trying to access. All right. I will conclude by currently drawing by drawing a comparison between where we are with PNA and LNA. So private network access has had a lifespan of around 4 years. I'm sure this is probably still going to be around because unless you've upgraded to Chrome 142 and above, this is possibly still going to exist. LNA has only been around for 3 months. The earlier version, PNA, was only found its way into Chrome, but LNA has found more adoption. It's made its way into Chrome, Edge, Firefox is trialing it as well. Unfortunately, both of these specs have not been able to solve port scanning, and port scanning is still possible. Both of them broke things, seriously broke things. Honestly, it caused a lot of confusion, possibly to users and attackers alike. PNA had its own set of challenges for which it was deprecated. It had to deal with dealing with mixed content policy. So that's when when HTTPS resources try to access HTTP or HTTPS services without a good certificate. It also had to deal with IoT devices or legacy routers that needed these updates where PNA access was actually required. So those are some of the challenges that led to PNA's downfall. LNA has its own set of challenges. Number one being users. Users are not going to know what those alerts are. If you look at the Chromium issue tracker, they are looking at making that prompt a little more intuitive. For now, just download my extension. But yes, that's one of the major challenges. The other challenge is that these mechanisms depend on intercepting different kind of JavaScript APIs, right? So for example, if fetch comes in, the browser is going to intercept that request and do its thing. But unfortunately, for example, protocols like WebSockets are not yet supported. So there is still scope for private network access in limited cases. Next, PNA did not really support any kind of centralized configuration for browsers. You could not configure any kind of policy in your organization to make sure your browsers exactly know what kind of PNA access is actually allowed to happen. But LNA, at least for Chrome, if you're an enterprise customer, they do allow you to create some kind of policy that explicitly allows you to define the set of websites that should have local network access allowed. And that is all I have for today. All the resources, references, my contact is all in this wiki that you can find in the QR code right here. I possibly finished way before I expected, so I can take questions if anyone has any.
So you mentioned that PNA started out and it took 4 years just to get Chrome to start using it, but LNA's been around for a few months and it's already got 3 browsers.
Sorry, it's the other way around. PNA was around for 4 years.
Oh.
Yeah, in fact, it was introduced in November 2021, deprecated a week before I submitted the CFP for this conference, which was very interesting. But yeah, LNA has been around for 3 months.
Okay. It just looks like LNA is getting adopted much faster than
It is, and it seems like it has good buy-in from Firefox, the Chromium project, and I think they're trying to solve a lot of problems that they saw with PNA.
Is there any way you can determine, let's say you're using a web browser, that it is using LNA?
Right. The question was, how can you detect whether your browser supports LNA? Unfortunately, that is not documented in a centralized location. But if you do use Chrome 142 and above, you know for sure that the browser is supporting LNA. I do not specifically remember what version of Edge supports LNA. Firefox is still in its trial version. It's not made its way into the production version yet. I hope that answers your question. Yes.
Does Safari or Apple have anything similar to this?
That's a great question. The question was, does Safari for Apple have any protections? Unfortunately, no. Safari allows, at the moment I have seen it allow private network or local network access. Yes, please.
I feel a little bit stupid asking this, but nevertheless. So I thought that SPA in browsers, like single origin protection in browsers, should protect from changing the origin of the URL, like from whatever script was loaded to trying to fetch a local host or whatever, like a local network. So why doesn't it work?
I'm sorry, which mechanism are you referring to?
Same origin in the browser.
Same origin, right. So the interesting thing about that is that even for CORS, that request actually makes its way to the remote service. So in the sense that, sorry, just gathering my thoughts here. Right. So for example, there's a number of different protections that could have stepped in, right? There's mixed content policy, there's CORS, but the initial GET request still managed to find its way prior to November 2020 to the remote resource. So if you had like a GET request to your router with set DNS, it would still make it through that remote resource.
I have just now realized that all my testing was primarily in Chrome in the last 4 years, so it already was in place, so that's why it didn't work. So makes sense. Thank you.
All right, I think we don't have any more questions. Thank you so much for being here, folks. I hope you have a great rest of the con. Thank you.